This is a tutorial to answer a question posed by Adrian in the NewTek LightWave forums on how to rig a train wheel. A link is in the description which will take you directly to the question posed. From Modeler, we will be creating three objects: the rod, the disc, and the casing for the rod. So let's start off with the disc. We'll go over to the primitives panel and select disc, then the numeric panel and activate it. We'll set the disc in the x-axis, and I'm going to set the number of sides to 12 simply because I just want to reduce the processing time it takes to render. I'm going to keep segments to 1, and the top and bottom I'll set to 0 because I want the disk to be flat. Center will be as is, and for the radius I'm going to set the x to 0, y to 500 and z to 500. So now it's activated. We have our disk ready for usage. So now I'm going to name this layer wheel. Now to create the second layer, which we're going to have the rod on, and we shall name this layer rod. With that done, let's go back to the primitives and select box. Then go over to the numeric panel and activate it. The width I'm going to set to 0 meters. Height I'm going to set to 100 millimeters. The depth I'm going to set to 3 meters, and the center coordinates I am going to set those to all 0, keep them as they were, and the axes I am going to make sure that it is set to the x axes. All the other settings I'm just going to leave as is. So with the box created, I'm now going to adjust the pivot point, which is currently at the origin of the grid. So in the right viewport, I'm going to change from the point mode into the polygon mode, as seen here, and select the rod and slide it towards the positive Z direction along the Z axis, so that the pivot point is going to be around here. Now you can use the pivot tool to position the pivot point wherever you want it to go by going into layers and then selecting the pivot tool, but for this particular exercise I'll just use the move tool to slide the rod into position. So holding down the control key, I'm going to force the motion in only one axis, and that axis is going to be the Z axis. In order to make sure that this rotates properly around the pitch, it's important to make sure that the rod works in conjunction with the way that LightWave prioritizes the positive Z axes. So by making sure that it's pointing towards positive Z should ensure that it rotates properly around the pitch. So with that done, let's create a new layer and make this one for the casing. Let's start off by naming the layer casing. We'll put the rod in the background and then go over to the disk primitive button, then go over to the numeric button and activate it. Right, so we'll make the Z axis the priority axis and set that. The sides I'm going to keep at 12, segments at 1. The only thing that I'm really going to change is going to be the radius coordinates, or the radius scales. X I'm going to make 150 millimeters. The Y radius I am going to make 150 millimeters as well. And the Z radius I am going to make that remain at 500 millimeters. So let's change the surface for the casing and give it the name casing. We will change the surface name for rod, call it rod, and we shall change the color and give it this color. And we'll go over to the wheel and change the surface name for that one, call it wheel, and give it this color. So looking at the wheel, you can see what it looks like here. The rod looks like this here, and the casing looks like this here. So now we'll just save the object and then go over to layout. Now in layout, where we now load our object. We'll just quickly switch over to quad view. From time to time, I sometimes find that the camera's visibility in the viewports gets in the way of what I want to do. So to get around that, I go to the scene editor, and then for camera, I deactivate the visibility for it. There. And as you can see, the visibility of the camera is no longer in the viewports. The camera is still in the viewport, it's just that it's not visible. So with that done, let's start rearranging things and adding nulls to the scene. We'll start off by creating two nulls. The first null we'll create and call it wheel null, and the second null we'll create and call that target null. The wheel null will rotate in concert with the wheel as it turns, and as it turns it will also take the pivot point of the rod with it. So let's start off by positioning the wheel null where we want it. We'll work in the right view and zoom in a bit. And we'll position the wheel null around here. So let's make sure that we are at 0 on our timeline, and then open up the wheel's motion options by pressing M on the keyboard. So now with that done, let's give the wheel some motion. Because I'm in the UK, my setup is set for 25 frames per second. So At frame 50, which is 2 seconds, I want to make sure that the wheel rotates 360 degrees around the pitch. So in order to make the wheel rotate continuously, we'll open up the graph editor and make changes to the pitch rotation. We'll filter the channels so that it only shows the rotation channels. So here you can see it says star.rot star, and that's our pattern that we are going to use in order to just filter everything else out and leave only the rotation channels listed, as you see here. So we're working on the pitch, so we select that channel and then highlight keyframe 50, and once done we'll change the post behavior to offset repeat, and as you can see, the graph's gradient for the pitch channel continues onwards and upwards until the end of the animation. So now we are going to make sure that the wheel null rotates with the wheel like this. So now we are going to select the wheel null and parent it to the wheel like this. So now when we move the timeline and see the wheel rotate, the wheel null will rotate with it in concert, like so. So with that done, let's work on the rod. We will start by moving the rod to the side, just so that we can see what we're doing a bit more clearly. So with that done, we're now going to set things up to make the rod's pivot point be controlled by the wheel null within the motion options for the wheel null. The aim being to ensure that the pivot point for the rod rotates with the wheel null. So to do that, within the motion options for the rod, under controllers and limits, we select the position tab, and under the position tab, or within the position tab, you'll see position item. And what that means is that we are going to choose which object we are going to use to control the rod's pivot point. And in the list we will select wheel null. We select world to make sure that the rotation of the world axis and not the object's local axis. And the two axes positions that will be controlled will be the Y position and the Z position. And the controller for the Y position is going to be the same as the item, which is the wheel null, and the Z position controller is going to be same as the item, which is the wheel null again. So the wheel null's Y position and Z positions will be used to control the pivot point of the rod. And as you can see, the rod now positions itself to the same coordinates as the wheel null. So as we see, the rod is pointing towards positive Z, which is fine, but what we want it to do is to have the end of the rod target the target null. So we are going to position the target null where we want it to be, and then change the settings for the rod to target it. And as you can see by the dotted line, it is targeting the target null. Although we can't see it, it seems to have disappeared. If we go over to wireframe view, you can see that it is actually targeting the target null. So if we switch over to perspective view in the top left viewport and zoom in a bit, and we change to VPR mode, you can see that we can't see the rod at all. The reason for this is because the rod itself is a single-sided object, and at the moment the normal for this object is pointing away from us and not towards the camera, and hence the reason why we can't see it. If the object was a double-sided object, then it would have two normals, and regardless of what direction it was rotated, we'd still be able to see it. But as it stands, it's a single-sided object, and we can only see it from when the normal is pointing towards us. So how do we fix this? Well, we can either change it to a double-sided polygon or go into Modeler and flip it. I'm going to go into Modeler and flip the normal. We will select the rod object in the rod layer, select the object, flip the normal by pressing F, and as you can see, the normal flips. Save the object and then return back to layout, and now you can see the rod. If we turn off the rod's target item, which is the target null, you see it returns back to its original position and is invisible to us because the normal is now flipping away from us. The solution to seeing both sides, of course, is to go into the surface editor for the rod and making the rod double-sided, and as you can see it. So we reactivate the rod's target item back to target null, and when we move the timeline, we get the motion that we want. The rod's pivot point is following the wheel null, and the rod itself is pointing and targeting the target null, just as we intended. So all that's left now is to position the casing. So we select the casing and move it to where we want it. So we'll zoom in and see what we've got. Now, as we see, the rod is not coming through the back of the casing, so that's good. And when we move the timeline so that the rod is on the opposite side, we can see that the rod is not escaping the casing from the front, which is good. So with everything set up, I'm going to create a preview, and I will change the length of the animation to 99 frames so that I can have a clean loop. And commence making my preview. So now that's done, we'll play it back, and there you have it, exactly as we wanted it. And that's how you create that type of motion. I hope that helped.